Hello everybody, this is N. Suresh Babu, MTech Structures 6th Sem student, Veltech, Dr. R. and Dr. S.R. Technical University, Avadi, Chennai 62. This project work titled Evaluation of Lateral Resistance of RCC Pile and Computation of Fragility Curve was submitted by me in partial fulfillment of the requirements for the award of the degree of Master of Technology in Structural Engineering for the examination held during May 2016 at Veltech, Dr. R. and Dr. S.R. Technical University, Avadi, Chennai 62. Now let me present about my project. Project title is Evaluation of Lateral Resistance of RCC Pile and Computation of Fragility Curve. The background of choosing the project I have given here. Past and recent earthquakes have demonstrated that pile supported structures such as the port facilities, bridges, etc. are prone to seismically induced damage in moderate to strong earthquakes. For example, the Lomoprita earthquake damaged Oakland Port, which is of a magnitude M6.9, and Kobe earthquake of magnitude 6.9 completely damaged the Kobe port, and the Haiti earthquake in the year 2010 damaged the Port-au-Prince. This shows the necessity of reconsideration in the seismic design philosophy of this type of structures to enhance their seismic performance. Hence, seismic probabilistic risk assessment studies for the structure and its components such as piles, piers, decks, etc. need to be carried out. The first seismic probabilistic risk assessment study was carried out for nuclear power plants in the early 70s and are being used now also. Fragility curves are commonly used in civil engineering to estimate the vulnerability of structures to earthquake. Many parameters involved in seismic design have uncertainty associated with them. Characterizing the probabilistic nature of these parameters can be done through the use of fragility curve, which assesses the probability whether the seismic demand placed on the structure exceeds the capacity condition. Now, a common definition of fragility is the quality of being easily broken or damaged. It is a common definition. Now, mathematically, fragility function is defined as a function that expresses the probability of exceedance of some clearly defined limit state, such as the function of some measure of environmental excitation, peak ground acceleration, peak ground velocity, or forces in an earthquake or hurricane, etc. In a simple way, a fragility function could express the uncertain level of shaking that a structure or its component can tolerate before it collapses. Hence, the present study is taken up for the evaluation of seismic fragility curve for a single RCC pile. My project report, I have organized my project report into 5 chapters. The chapter 1, it's more of a brief introduction and the application of fragility, and the scope of the project I have discussed. The chapter 2 concerns with the literature review, and chapter 3 discusses the estimation of load capacities of pile, selection of ground motion, synthetic and real-time ground motion data, and lateral analysis of pile using OpenSysPL FM software. Chapter 4 presents the methodology used in the computation of fragility curve, setting up of desired limit state capacities, nonlinear dynamic analysis, time history analysis, then development of PSDA model, fragility curve, etc. are discussed. Chapter 5 presents the summary, significant conclusions and contributions done from the present study. Now, the scope of the project. Actually, this project has been carried out in 2 phases. In the phase 1 of the study, a pile, which is a part of the pile foundation system, supporting an elevated filtered water storage tank of an industry located at Chennai, chosen for analysis and design. The actual soil investigation data of various field and lab tests conducted for the industry site at Chennai is obtained and used. The load carrying capacity of pile in axial, uplift and lateral are found out. The figure shows elevation of filtered water storage tank and also the soil bore log details with channel penetration test N values. Now the design inputs, the inside diameter of the tank is 8 meters, height of the tank above ground level 10.5 meter, location is Chennai, storage liquid is filtered water, and based on the dead load and live load calculation, the following load details are obtained. Dead load is 234 kilonewtons, live load is 5026 kilonewton, and the total design load is 5260 kilonewton, that is 526 tons. Now, based on the soil bore log details, it is seen that beyond a depth of 22 meter, weathered rock, that too granitic gneiss type of rock, is available. So, considering this, the depth of foundation is chosen as 23 meter, and the pile type is N bearing pile is considered. Now, the diameter of pile considered is 450 mm. Naturally, the socketing depth will be twice the diameter, which is equal to 0.9 meter into the rock, and the concrete characteristic compressive strength is considered as 25 Newton per mm square, and for the steel grade it is 450 Newton per mm square. Here, I have to say one thing. Generally, for piles, M35 is generally considered, but in my study I have considered M25 as a concrete grade. Now, as per IS 2911-2001 part 1 of section 2, the axial load capacity, the uplift load capacity and the lateral pile load capacity are calculated. Now, for calculating the lateral load capacity, we require the depth of fixity, which in turn is based on the stiffness factor of the pile, based on the flexural rigidity of the pile and modulus of subgrade reaction. And the lateral capacity, load capacity is calculated for a permissible lateral deflection of 5 mm. Now the figure shows the schematic representation of the pile load capacities and the soil strata details. Now this figure shows the roof slab orientation of piles, the raft slab orientation of piles, the cross-sectional details, cross-sectional details and elevation of 450 mm diameter pile. Now, in the phase 2 of the project, the scope of the project is establishing the fragility curve. Now, in this phase 2, the pile is subjected to a series of time history analysis with synthetic and natural ground motion records of varying peak ground acceleration using a FEM software called OpenSea's PL. The maximum lateral deflection of the pile at top for each PJ is recorded. From the analysis, the probabilistic seismic demand model (PSDM) and fragility curve for various limit state serviceability conditions are developed. So, collection of earthquake ground motion data. For a reliable estimate of the response of the pile to the ground motion, a suit of at least 11 pairs of ground motion are required. It is in general. Though India had experienced several major earthquakes in last few decades, the number of available earthquake records for Indian region is limited. Only 13 pairs are available in the website of CSMD. From this data, 6 pairs of natural ground motion data are selected and used for time history analysis in my project. Now, in order to have statistically sufficient number of ground motions, a suite of synthetic ground motion data, 22 pairs of records given in FEMA website are also selected and used in the study. These are synthetic ground motion data. Now, the synthetic ground motion records are scaled from 0.1G to 1G linearly with the rate of increment of 0.0209 G. Using these 22 pairs, that is 44 synthetic ground motion records, 44 time history analyses are performed. Now, the natural ground motion records are used as such without scaling. These 6 pairs, that is 12 natural ground motion records, using this 12 time history analysis are performed. Now OpenSysPL, it is a open source firm-based software and is a graphical user interface for three-dimensional ground structure response. In this study, a finite element simulation of a single RCC pile is conducted using this OpenSysPL software by modeling pile as a beam element and soil as a 8-noded brick element. The pile is subjected to an axial load of 850 kN and further it is subjected to earthquakes of different PGA. Then what is time history analysis? Time history analysis is nothing but a non-linear dynamic analysis. It is a method to describe the actual behavior of a structure during an earthquake. And this method is based on the numerical integration of the differential equation of motion by considering the elastoplastic deformation of the structural element. In this method, a mathematical model of the structure is subjected to accelerations from earthquake records. This method consists of step-by-step direct integration over a time interval. The equations of motion are solved with the displacements, velocities and accelerations of previous step, which serves as initial function. The equation of motion is mx dot dot plus cx dot plus kx is equal to p of t, where k is the stiffness matrix, c is the damping matrix and m is the diagonal matrix. P of t includes ground acceleration. The displacements, velocities and accelerations are determined related to ground motion. Now, the figure shows the various pile data used in the OpenSys simulation and soil data used in the OpenSys simulation, and this figure shows the FEM modeling of axial loaded pile in OpenSysPL. Now the input ground motion data, synthetic ground motion data shown in this figure. The pile response time histories is also shown in this figure. The lateral displacement of the pile at various EL, that is at ground level where the EL is 0 meter, at minus 5 meter, at minus 10.83 meter, at minus 16.67 meter and minus 22.5 meter, that is below the ground level, is shown graphically. So that this tabular column shows the maximum displacement obtained for the particular by conducting the non-linear dynamic analysis for each case. Now, the P delta analysis option in StatPro can also be used to compute the lateral deflection of an axial loaded pile when it is subject to lateral loads. In this, the pile has been modeled with 19 nodes and 18 beam elements, each of 1.25 meter length. The bottom of the pile is assigned fixed and condition, and the soil is represented by a series of linear elastic springs at each node level. The spring stiffness of the linear springs have been estimated using Newmark's distribution. The stiffness of the first spring, the intermediate spring and the last spring have been estimated from the below mentioned equations. Then using the StatPro, the maximum displacement available obtained is shown in this figure. And a comparison between the results of StatPro analysis and OpenSys analysis of ground motion data is placed in this figure. A graph showing the PGA versus displacement obtained using StatPro and OpenSys schematically represented here. And the stat output result shows a linear relation between the applied lateral and corresponding lateral displacement. The OpenSysPL output results show a non-linear relation between the applied lateral load PGA and the corresponding lateral displacement. Hence, the results obtained from the time history analysis of OpenSysPL is used in the present study for the computation of fragility curve. Now, computation of fragility curve. So, the fragility function represents the probability of exceedance of the selected engineering demand parameter for a selected structural limit state or damage state for a specific ground motion intensity measure IM, and in this case it is P ground acceleration, that is PGA. Generally, fragility curves will be combined with the seismic hazard curves, which represents the probability of occurrence of earthquake of a given maximum intensity for further probabilistic assessment of seismic risk. Indian seismic hazard curves are available in terms of PGA. Hence, the P ground acceleration has been chosen as the intensity measure. The damage of the structure can be correlated to structural response when subjected to earthquake loading. Hence, lateral displacement of pile has been chosen as engineering demand parameter. Then the next option is setting up the damage state or limit state of service or failure criteria. So 4 damage states are considered in the present study. One is damage initiation, which is set to 1% of the pile diameter. Damage limitation set to 2% of the pile diameter. Significant damage set to 3% of pile diameter. And collapse prevention or near collapse set to 4% of the pile diameter. And this figure shows the graphical representation of this damage states. The fragility function is a log normal cumulative distribution function to provide a continuous estimate of the probability of collapse as a function of selected seismic intensity measure. So it is a log normal cumulative distribution, and this slide explains the step-by-step procedure in the computation of fragility curve. Now, the probabilistic seismic demand model, which expresses the engineering demand parameter as a function of intensity measure, has to be developed first. For each analysis, peak responses are recorded and plotted versus the value of the intensity measure in logarithmic scale. A regression analysis of this data is then used to estimate the constants of PSDMs, which is subsequently used for developing fragility curves. It is fitted through the power law equation. The flowchart for the development of fragility curve is shown here. First is finite element model of the pile, then the earthquake motion data input, then time stay analysis for conducting the time stay analysis. Next is development of PSDM model, which is PGA versus displacement, and then the setting up of the failure criteria, and the final step is development of fragility curve. So, the following figures show the various fragility curves developed for the four damage states, for both for synthetic ground motion data and for the natural ground motion data. Conclusion: in this study, a method for the evaluation of seismic fragility curve of pile is presented, and this method belongs to the category of analytical approaches to the fragility estimation. This method is demonstrated through an application of a single board cast in situ pile designed for a pile foundation system. Since the pile foundation is designed for Chennai, located in seismic zone 3, having a PGA value of 0.16 G as per zone factor IS 1893-2002, and further, the lateral capacity of pile is arrived by assuming a permissible lateral deflection of 5 mm. The probability of exceedance of 0.16 G is 80%. It can be interpreted from the fragility curves. Similarly, for a PJ value of 0.16 G, the probability of exceedance is 17% for the damage state, 3% for the damage state SD, and 1% for the damage state CP. Since the maximum PJ value as per IS 1893-2002 is 0.36 for zone 5, it is seen from the fragility curves for synthetic ground motion data that 100% probability of exceedance for damage states DI and DL of limit state condition of serviceability, then 92%, 72% probability of exceedance for the damage states significant damage and collapse prevention is seen. From the fragility curves based on the natural ground motion data, it is seen that for a PJ value of 0.16 G and for limit state condition of serviceability of 1%, 2%, 3%, 4% of pile diameter, the probability of exceedance is 83%, 48%, 27%, and 15% respectively. It can be seen that the exceedance probabilities for the pile using natural accelerogram set is found to be higher than that of synthetic accelerogram set. The fragility curves derived so far presents the probability that the pile considered will fail if subjected to earthquakes of a given intensity in terms of PGA. However, to assess the risk of any structures, this fragility curve should be combined with the seismic hazard curve, which represents the probability of occurrence of an earthquake of a given maximum intensity. Thank you.